Thanks to be here. And I'm Marco Genovese, and I'm a pre-sales engineer in Stormshield. We have a little bit more time because the previous presentation has finished in advance. And today I would like to talk with you about 5 underestimated weaknesses of industrial protocol. I will explain you why I would like to talk about this, but the first thing is to try to understand, for example, what is Stormshield, because Stormshield is a fully owned subsidiary of Airbus into a division called Airbus Defence and Space. Airbus doesn't make only aircraft or helicopter, but they do also satellite, and when it comes to satellite, it comes to security communication. To secure the communication, you need to create a secure backbone. Airbus is also the biggest Tetra network producer in the world with Motorola. So when it comes to create a Tetra infrastructure to the police or the Red Cross or military, you need to secure this backbone. Now, one of the issues of securing sensitive infrastructure, and I'm talking about Tetra network, but also industrial network, the issue is that the cybersecurity market is quite fast. I don't know if someone of you remember a German firewall called Astaro some years ago. Raise the hand who if someone of you is remembering this firewall. Nobody is remembering this firewall. So Astaro was a German firewall, deeply used in military infrastructure. One day comes Sophos, UK. They bought the firewall. After a few months, they bought CyberRoam, which was an Indian firewall. They merged the two technology, and after a few months, they moved the headquarters in the US. So, in 1 year, you don't know anymore if the updates are coming from Germany, from UK, from India, or from US. So, in that period, in 2013, Airbus say, okay, let's stop 1 second. We want to create a pole of cybersecurity which is totally European, and in this way we can guarantee that the cybersecurity is maintained across the time, so we can implement in a sensitive environment like industrial environment a firewall and maintain it. In Stormshield, I have been product manager, so I've collected all the requirements from the customers. I helped our R&D to build our industrial firewall, and now I'm in the industrial business line. So I'm following and coordinating all the industrial product and industrial project that we have all around the world. This gives me the possibility to deal with different sectors. When you work in the industrial cybersecurity, sometimes you know people that has worked for 30 years in building automation. They know everything about BACnet, but they don't know anything about IEC 104. People coming from the energy world, they know IEC 104, they don't know Modbus, for example. So this job allows me to exchange with different customers and system integrators all around the globe in different sectors. So water distribution in Poland, in Germany, oil and gas with Yokogawa, for example, in Middle East, and so on. Of course, there are different protocols, there are different questions, and I have a privileged view because I don't see this project from the top, but I see it from the bottom. Why from the bottom? Because when there is an issue, sometimes you cannot go there. And so you receive a TCP dump of the problem. You connect in SSH and you do a TCP dump. So you don't even care if the communication is between a machine which is developed by Schneider or Yokogawa or General Electric, but what you care is the language that this device is speaking in the network. Speaking with the customers, I have seen that there are some weak points of industrial protocol that they are not clear or misunderstood, and some customers sometimes they said, oh, I was not aware about these things. So today I was to make 5 considerations that you have to keep in mind when you want to secure an industrial network. No matter if you are going to use Belden, Stormshield, Fortinet, or whatever you are going to use. Keep in mind these 5 points. First things is, this one is the ICS architecture, and I think everybody knows it. So at the level 0, we have sensor and actuator. Sensor and actuator are managed by level 1 by PLC. PLC are orchestrated by level 2. At this level, at level 2, you can decide, you can control in real time the production. At level 3, you start to have also historical data. So you can decide if tomorrow you want to reduce or to increment the production, and then you have level 4, where you have the IT. So one of the key points that you have to think is that more you go in proximity to level 0 when you launch an attack, and more you can create damage. You can even kill people, because at level 0, you don't move data, you move things, you move objects. Now, in order to secure this pyramid, there is a regulation, which is the IEC 62443. And the IEC 62443 says that we have separated the pyramid in zone and conduit. So we have to identify zone, we have to identify what kind of communication are authorized between zone, what kind of languages are authorized between zone. And for every zone and conduit, they have identified 7 essential functions, which are identification and authentication control, usage control, system integrity, data confidentiality, restricted data flow, which is the segmentation, timely response to events, so react in real time, and resource availability. With all these 7 functions, in most of the conventions where I go around the world, all the people finish to talk about shutdown, to show that there is a PLC exposed in internet. This is not a real issue. This is a segmentation issue. It's just one point of the 7 points that they are proposed by the 62443. So today, I would like to tell you that we have to think beyond the perimeter. Yes, an exposed PLC can be an issue, but it's not the only issue. There are other points that we have to take in mind when we are going to operate on the cybersecurity of an industrial network. Here are the points. First one is the latency. So, when you are going to introduce a new technology in your network to increase the cybersecurity of your network, you have to think about, is the latency that this technology is going to introduce in my network compatible with my network? Why? Because in industrial network, there are some protocols like GOOS SV in the electric world, or Profinet real-time, Profinet RT, Profinet ERT, Profinet isochronous real-time in manufacturing, that they are not friendly with latency. Most of the solutions that there are on the market are signature-based. So vendor didn't reinvent the wheel. They had a firewall with an IPS system. This IPS system has a huge database of signature to detect attack. At a certain moment, they said, okay, the market is asking to do deep inspection on industrial protocol. What we can do? We can create signature to detect industrial command. We use the same engine, and with this engine, we are going to detect industrial command. Now, what's the issue? The issue is that working in this way, you have to download a huge database of signature, Each packet that is passing in your network needs to be matched with this huge database, and this is going to introduce latency. Sometimes this latency is not fully compatible with your network. So the first things that you have to ask is to really be sure that you don't have issue for this. The second point is the integrity. Now, I think everybody knows that most of the industrial protocols are not encrypted, are not authenticated. Modbus is a classical example. So you don't need some Italian guy coming here to tell you this. But I've discovered things that probably is not so well known. The thing is that there are some industrial protocols that they provide a certain level of encryption authentication. OPC. OPC, for example, is a protocol that allows you to use certificates to authenticate to cipher. OPC is used a lot in the water distribution system, for example, because every geographically distributed network has different sensors from different brands. At a certain moment, it's easier to create an abstraction layer, and OPC is not a field bus. So OPC is a protocol that is used to create an abstraction. Now, I've discussed with several customers in the water distribution field. We have customers in Poland, we have customers in Germany, we have customers in Italy. Probably is the sector where Stormshield has more customers. And here you can see a classical example. You can see a device sending data with Modbus to the OPC server, and then the customer, which is on the left side, that is connecting to the OPC server to retrieve the information. Now, with this model, I have seen two things. The customers type login and password to enter to the OPC server, and he thinks that his connection is safe. But it's because he doesn't have visibility of what there is on the other side. If you have an OPC server, the safe of your connection is terminating to the OPC server. But on the other side, you are collecting data with Modbus, which are unclear. If I wanted to inject data in your network, I don't have to hack the OPC server. I can inject fake data from the Modbus side. And most of the customers, at least 8 customers on 10, they didn't have this idea, they didn't have the idea that part of the configuration was unclear. Another interesting point is that even if industrial protocols are providing a certain level of security, nobody is using it. Why? Because the people who is going to install a PLC or install an industrial device, they know nothing about PKI. They are scared about the management of a PKI. What happens when a certificate expires? What happens when I have to publish a revocation list? What happens when the certification authority expires? So in most of the cases, I have seen that they don't switch on the security part. And in many cases, when, for example, in OPC, when you start to use the authentication, the encryption, they forgot to switch off the security mode none, because they do the minimum effort to make the customer happy, but they don't have the skill to protect a network. UPC UA, yeah. Yes, mainly OPC UA. I try always to avoid OPC Classic because they are and we will see it probably later. I don't know if I have a slide on OPC Classic. And so, this is OPC, but it can be another industrial protocol. I have seen, so one of the solutions, what can be? Maybe you can consider that nobody will be able to manage the security on the industrial protocol side, and so you can create a backbone with dedicated device to create a VPN backbone, and to assume that the people who is configuring the OT device will do mistakes. we have customers, they have done this. So they have created a VPN with external device. So even if someone makes a mistakes on the configuration of the OT infrastructure, in any case, the communication will be encrypted. Then, are you sure that your network is speaking a standard language? Why? RFC in the IT world are quite strict. RFC in the OT world are more suggestion. So this is something that I have learned. This one is an example. Even when a protocol is standard, every standard protocol allows you to create custom classes, custom device. This one is CIP. CIP is a protocol initially developed by Rockwell, now maintained by ODVA. It comes with Ethernet IP, so usually they come together. And the CIP protocol has some specific range where you can create your own classes. CIP is an object-oriented protocol, so you can represent a pressure sensor or a temperature sensor as object with classes, attributes, values, and so on. So you have a range where you can create whatever you want. If you go in internet and you search, you can do it at home. You can search SIP pickup, you download it, you open with Wireshark, and you will see that most of the classes that you find are in the custom range. So if you are going to use a signature-based technology to do deep inspection, how it is possible to create a signature to detect something that you don't know? It's not possible. You need to know something if you want to create a signature. What's the issue here? The issue is, first case, the custom class is blocked by the solution that I'm putting in place, or the command is passing in a totally transparent way through my solution, and I'm not even able to detect this part. So whatever you want to implement in your network, it has to be flexible enough in order to be able to manage this type of issue. This one is another example, LACBus. LACBus is a protocol that has been developed by Lacroix Software. Lacroix Software is one of the leaders in the world for the creation of a sensor for the water distribution. They have a production site in Poland, for example. They have invented two languages called LACBus and SoftBus. LACBus is a kind of new version of SoftBus, but this communication is detected as Modbus. We know that it's LACBus because the very first communication is always a Modbus packet to this specific reference, to this specific read holding register. And the answer is the so-called control table. In a control table, there is written, if we are speaking LACBus, Modbus, LACBus or SoftBus, at which address you store historical data, at which address you store real-time data, and so on. So this type of communication is detected by most of the solution on the market as pure Modbus, but it's completely different. So there are a lot of cases. UMAS is another case of Modbus traffic, which is not intended to move data, but to move command for the configuration of the PLC. So even the standard language, sometimes they are used to embed other languages, and it's not really easy to detect this. Now, resiliency. This one is also interesting. Try to imagine you are a web developer. You develop your web server, you call it super web server, and you comes out with version 1.0. You go online, in 5 minutes someone will crash your system with a malformed packet. You find the bug, you fix the bug, you go online with version 1.1, and maybe it's 10 minutes. 1.2, half an hour. 1.3, 1 day. When you come to version 10, probably you are robust enough. Now, even if they don't tell to you, but the industrial vendor, they have been they don't have the same experience and skill of the people who develop something that has to be placed in internet. They have developed for 40 years in closed environment. Try to imagine Siemens. You have a Siemens PLC, you have a Siemens client called TIA Portal, you have even a Siemens protocol called S7. So they do qualification tests, okay, it's working. But when you put something in the real world, lot of malformed packets are coming and people are trying to crash your system. Remember that every industrial protocol is based on traditional network protocol. Modbus is based on TCP, which is based on IP. So if I want to attack Modbus, I don't have necessarily to attack the Modbus command. I can also attack the layer at IP level or TCP level. Now, when you want to secure a communication, it's really, really important to think that OT devices are more sensitive than IT devices to malformed packet. It's more easy to do a denial of service on an OT device than to do a denial of service on an IT device. So it's not only a matter to understand what are the commands that they are passing, but it's also important to block all the commands that are not authorized, all the commands that they are malformed, all the commands that can lead to a crash of the system. Then, the last one, who has access to your network? This one is really nice because discussing with customers, sometimes they say, yes, but this one is an industrial network. Even if someone has access, you need to be an expert to do damage in this network. Nothing is more wrong than this. Why? Because industrial command has been created with only one target in mind: simplify the deployment. So industrial command like OPC, BACnet, CIP, especially the object-oriented command, they have been created to simplify the life of the installer. One example is BACnet, for example. BACnet is a protocol that you don't even need really good knowledge to understand what it's doing, because even the commands are human readable. When you plug a BACnet device in the network, the first things that the BACnet device is going to do is to announce himself in broadcast mode to the whole network and say, hello, I am a BACnet device, I am a fire alarm sensor. Do we have other fire alarm sensor in the network? And you see that all the alarm sensors are going to answer. I am device number thought, I am device, I'm device, I'm device. And the interesting things of BACnet is, thanks to the BACnet router, they are able to propagate this request even outside of your network, bypassing a firewall or a router that you have in your network. This is really interesting. So, everybody can simply take a TCP dump of an industrial network to have a complete view of what there is in the industrial network. And every protocol has specific command to do this. Bootstrap command, search command. So we can talk about S7 with Profinet. With Profinet, for example, there are also commands to announce himself to the network and to discover the network. And you don't need to be an expert because there are a lot of graphical user interface like BACnet Explorer, OPC, GUI, lot of tools that you can download from internet. You can just open in your network and they will discover the network. And then when you have a graphical representation and you have temperature of a boiler, increase the temperature, reduce the temperature, you don't need to be an expert, an engineer, to click on a button to increase or decrease the temperature. So it's more easy to make damage into an industrial network than to do damage in a traditional IT network. So this was my last slide. The idea of this presentation, from my point of view, is that if you want to secure an industrial network, you need absolutely to understand the communication that there are in the industrial network. I've seen that, I've discussed with a lot of vendors from Siemens, Schneider, Yokogawa, and so on, and there are training. They are starting to produce training. Some of them, they are more advanced than the other. But the training are always the same. You have Semantic PLC. You have your TIA portal. If you want to configure the PLC to do something, you have to press this button. But nobody is going to tell you what happened on the network side from the moment that you are pressing a button and the command is reaching on the other side. Each protocol has his own peculiarity, and you have to take in consideration this peculiarity in order to understand the better way to secure the protocol and to secure the network. So, with this slide, I've finished. And